So in this short video lecture, we are going to give the solution to this question 2 in our exercise, where we have been asked to expand in Fourier series the function f of x equals to x squared in the interval from 0 to 2 pi. So we know that f of x is given by a naught over 2 plus summation n from 1 to infinity an cos nx plus bn sin nx. So this is the Fourier series formula, where a naught is given by 1 over pi integral from 0, for this case because we have 0 to 2 pi, so 0 to 2 pi of f of x dx, because this is a function is period 2 pi, and then an is 1 over pi, limits will be 0 to 2 pi f of x, and then cosine nx dx, and then bn equals to 1 over pi 0 to 2 pi f of x, and then sine nx dx. So please don't assume that this function is even, because the interval given 0 to 2 pi doesn't involve the negative values of x. So don't be tempted to say that this is an even function and then you only expand in the cosine series alone. You'll get it wrong. So you have to be very careful for you to conclude that the function is even. This, when they specify the limits of x, is what determines whether you can say that in that given interval given the function is even or not. But you should not just say because f of x, generally it's an even function, then you conclude that you expand only in cosine function. That will give you a wrong answer. So be careful. You only conclude that the function is even or odd depending on the function itself and also the limits where the x or the function is defined. So let's give the values. So this question 2. So a naught will be given by 1 over pi 0 to 2 pi, and then f of x is x squared dx. So this will give us 1 over pi into x cubed over 3, and then you put limits 2 pi to 0, from 0 to 2 pi. So when you put in the limits, you should get 8 pi squared over 3. And then an will be 1 over pi integral from 0 to 2 pi, and then x squared cosine nx dx. So here you will use integration by parts twice. So whereby u is x squared, so which means du is 2x dx, and then dv will be cos nx dx, so which means v, you integrate this one, you get sine nx over n. So we know the integral of u dv is uv minus integral of v du. So this will be an equals to 1 over pi integral from 0 to 2 pi x squared cosine nx dx equals to 1 over pi. So uv will be x squared and then sine nx over n, and then put limits 0 to 2 pi, and then minus v du. So this v and then this du. So I factor out 2 over n integral so x and then sine nx dx at limits 0 to 2 pi. So this is what we have. So you see, this will be, when you put 2 pi here, so will be sine of 360, multiples of 360, and that gives us 0. So therefore, upper limit is 0 and also lower limit is 0. So therefore, all this part goes to 0. So we have 1 over, I can say minus 2 over n pi integral from 0 to 2 pi. So this is an. And then x sine nx dx. Because this is the part that remains, then we multiply by this factor 1 over pi. So this also use integration by parts. You let u to be x, which means the u is dx, and dv you let it to be sine nx dx, which tells us that v will be negative sine negative cos nx over n, n sine n will be given by negative cos nx over n, so there's a negative here. So therefore, an will be given by, so when I have minus 2 over n pi uv, so I'll have I have this and this, so we have minus x cos n x over n, limits is 0 to 2 pi, and then minus v, the integral of v du. So the plus integral of v du. So this one, so we have 1 over n integral 0 to 2 pi, so cosine of nx dx. So this means we'll be getting, so when you put for x 2 pi, so this is the same as cosine of multiples of 360, and cosine of 360 is 1. So we'll have 1, and then when you put in 0, so the lower limit will be 0. So this just give us, so minus 2 over n. So I can factor out, actually I can factor out n, so I say n squared pi. Then do the same thing as saying minus minus is positive, and then x cosine nx 0 to pi, so plus 1 over n. So I integrating this one, I get, I'll have sine nx over n. Then I put in the limits from 0 to 2 pi, and then so upper limit, so the sine of multiples of 360, that gives me 0, and when I put sine of 0, you get 0. So this part will be 0. So this part goes to 0. So that I have an will be given by 2 over n squared pi into, so 2 pi, and then cosine of 2 pi n, but lower limit will be 0 because of this factor here. But we know that the value of cosine of 2 pi times multiples of 2 pi is 1. So this is the same thing as just having 2 over n squared pi times 2 pi. So this gives us pi and pi cancels out. So we have 4 over n squared. So this is our an. So an is given by 4 over n squared. And then lastly, bn will be given by integral from 1 over pi 0 to 2 pi of x squared sine of nx dx. So also you use integration by parts twice. And when you do that one, like what you've done for an, you get minus 1 over n pi, and then x squared cosine nx. So putting in the limits, 0 to 2 pi, and then plus 2 over n pi, integral from 0 to 2 pi x cos nx dx. So we are just applying integration by parts. So we'll have bn equals to minus 4 pi over n, and then minus 2 over pi n squared, then integral from 0 to 2 pi. So remember, we apply also integration by parts on this term twice. On this term, so sine nx dx. So bn reduces to minus 4 pi over n, because the integral of this part here goes to 0. Since we'll have cosine of nx over n, so 0 to 2 pi. So when you put 2 pi, so cosine of 360 and multiples of 360 will give you 1. So 1 minus 1 is 0. So 0 times this one gives you 0. So this is the value for bn. So therefore, putting a naught as 8 pi squared over 3, bn as minus 4 pi over n, and an as 4 over n squared from what we have obtained, then the Fourier series of f of x given by x squared in the interval 0 to 2 pi is given by x squared, which is the same as the function, equals to, so a naught divided by 2 gives you 4 pi squared over 3 plus, so we have 4, we have the value of, let me just write, plus summation n from 1 to infinity. So a naught, an is given by 4 n squared cosine of nx plus bn. So bn is minus 4 pi over n, and then sine nx. Or you can write it as x squared, which is the function, is 4 pi squared over 3 plus, this one can be written as 4 summation n from 1 to infinity cos nx over n squared minus 4 pi summation n from 1 to infinity of sine nx over n. So this is the Fourier series for that given function. So you can write a few times. The expanded form will just leave your answer in this form here.